Let us start today's session 4, programming with Python. In the last session, we have looked at simple programs, how to write simple programs, which are typically less than 10 statements in it, right? In this session, we are going to learn something called selection flow, okay? Before we go with selection flow, we need to understand what relational operators are. In Python, we already understood the arithmetic operators. Now we are going to understand relational operators. Relational operators are used to compare the quantities. Let us look at some examples. There are 6 relational operators in Python, and the first one is less than. Using this symbol, we can represent the less than operator. Second one is less than or equal to, greater than or equal to, and the equality operator is double equal to because single equal to is used for assignment operation. Hence, we use double equal to for equality check. And the final one or the last one is a not equal to operator. These are the 6 relational operators. Okay. These relational operators are used to construct conditions. Let us look at some examples. If you want to compare two integer values, you can use this less than operator as shown in this example. 15 less than 18. If you want to compare two float values or decimal numbers, then you can use something as shown in this example, 18.5 less than 11.2. Similarly, you can also compare strings. So here the string C is compared against string F. In the last example, string cat is compared against string cap. And remember, in Python, strings are enclosed within either single quotes or double quotes. Here we have used single quotes to embed the strings within. And now, as a result, when you apply a relational operator between two numbers or two strings, the result would be a Boolean, which is nothing but either true or false. So, if you ask yourself, is 15 less than 18? Your mind says no. Sorry, your mind says yes. Hence, 15 less than 18 is true. 15 less than 18 evaluates to true. And 18.5 less than 11.2 evaluates to false. The string C less than string F evaluates to true. When you compare strings, especially in this case, it is two characters that you are comparing in the form of strings. The alphabetical order is considered. So the question you need to ask yourself is whether the character C comes before F. Yes, C comes before F. Hence, the less than operator between these two string constants evaluates to true. And now the final one, the cat less than cap. How does it evaluate to false? So, when the strings are compared, the first character from cat is compared against the first character of cap. Both are C characters. Both are the characters C. So it cannot derive or decide anything there. So it moves ahead and checks the second character in cat against the second character in cap. Again, both the characters are same. We cannot decide. Hence, now it goes to third character in cat, which is T, compared against the third character in cap, which is P. Now the question is, does a T, lowercase t, come before lowercase p? The answer is no. Hence, finally, the condition cat less than cap evaluates to false. This is how relational operators can be applied between two numbers. The numbers can be either integers or floats, or you can also apply them on character type of data or string type of data, right? And Using relational operators, we construct conditions. Here 15 less than 18 is a condition. 18.5 less than 11.2 is another condition. String C less than string F is also another condition. And finally, the string cat less than string cap is also a condition. Every condition evaluates to a Boolean value, either true or false. Also, if you check whether 15 less than 15, this condition evaluates to false because a number is not less than to itself, any number. 18.5 less than 18.5 is also false. The character C or the string C is less than string C is also false. Similarly, the string cat less than string cat is also false. So when you apply less than operator between the same values, that condition evaluates to false. All right, let's move on to the next operator, less than or equal to. So use the same numbers, but change the operator in between to understand this. Okay, now 15 less than or equal to 18. Here you have to check for whether 15 is less than 18 or whether 15 is equal to 18. Okay, if either of the cases, if either of the conditions is true, the condition evaluates to true. So 15 less than or equal to 18 evaluates to true because 15 is less than 18. It need not be equal to because 15 is already less than 18, you don't check for equality, right? So 15 less than or equal to 18 finally evaluates to true. And 18.5 less than or equal to 11.2 evaluates to false. The string C less than or equal to string F evaluates to true, and string cat less than or equal to string cat evaluates to false. And you can also apply less than or equal to between the same values. As you see here, 15 less than or equal to 15 is true. 18.5 less than or equal to 11.2 is true. String C is less than or equal to string C is true. Similarly, the string cat less than or equal to string cat also evaluates to true. Okay. When you consider the example 15 less than or equal to 15, how does it become true? Because here you're, as I said, you're checking two things. First thing you will check is whether 15 is less than 15. No, 15 is not less than 15. However, you are also going to check whether 15 is equal to 15. Yes, 15 is equal to 15. So finally, this condition evaluates to true. The next relational operator is greater than, and you can apply the greater than operator between the same numbers and evaluate the conditions, right? 15 greater than 18 evaluates to false. 18.5 greater than 11.2 evaluates to true. The string C greater than string F evaluates to false. The string cat greater than string cat evaluates to true, right? Similarly, 15 greater than 15 evaluates to false. 18.5 greater than 18.5 evaluates to false. String C greater than string C evaluates to false. String cat greater than string cat evaluates to false. The same numbers cannot be greater than to themselves or than themselves. Similarly, the next operator is greater than or equal to 15 greater than or equal to 18. Okay, this is going to be false, correct? 18.5 greater than or equal to 11.2 condition is going to become true, right? Similarly, string C is greater than or equal to string F condition is going to be false. The string cat is greater than or equal to string cat is going to become true. All right. Similarly, you can apply the greater than or equal to operator between the same numbers. Okay. So 15 greater than or equal to 15 is true. 18.5 greater than or equal to 18.5 is again true. C, the string C greater than or equal to string C is also true. The condition string cat greater than or equal to string cat is also going to be true. The next relational operator is equality operator or double equal to operator. 15 equal to true, 15 equal to equality operator is this is right. So you have to use two equal to symbols to check whether the two quantities or two variables or two constants are same or not. So is 15 equal to 18? No, it is not. So the first condition becomes false. 18.5 equal to 11.2. No, it is not. So the second condition also becomes false. The string C is equal to string F. No, not right. So that also becomes false. The string cat equal to string cap also becomes false. So all these four conditions are going to evaluate to false. Finally, sorry, here the operator should be equal to 15 equal to 15. The condition 15 equal to 15 should be true, right? And 18.5 equal to 18.5 should be true. The string C equal to string C should be equal to true. The string cat equal to string cat should be equal to true. Okay. There is a typo here. The less than operator here should be interpreted as double equal to symbol. And the last relational operator is not equal to 15 not equal to 18. Yes, 15 is not equal to 18, which is true. So this condition evaluates to true. 18.5 is not equal to 11.2. True. String C is not equal to string F. True. String cat is not equal to string cat. True. Right? Similarly, 15 not equal to 15 is false. 18.5 not equal to 18.5 is false. The string C is not equal to string C is going to be false. And the string cat not equal to string cat is going to become false. This is how you have to understand all the six relational operators and how to build the conditions using these relational operators. So if you look at a simple code here, how do you evaluate this and how do you know the output? You can simply use these conditions in the print function directly in Python. So I am going to use all the six relational operators on the same two numbers, 15 and 18. So the operands are not going to change. 15 and 18 are going to be my operands, but the operator changes in every print. So the six relational operators less than or equal to, greater than or equal to, and not equal to. All these six relational operators have been applied on these operands, and finally the result would be for the first statement, what would be the result? The result would be true. Second one, yes, it would be true. Third one should be false. Fourth, it should be false. Fifth, false. Sixth is true. All right, now let us go and practice this. All right, so I'm going to open a file. You can create a new file if you want, but I'm just going to open an existing file and I will overwrite the content. All right, so let us go to the file and I'm going to have some print statements. Let us use the same data, 15 less than 18. Right? And to make it fast, you can just copy paste this word 6 times as we have to experiment with six relational operators. greater than or equal to equality check double equal to and not equal. All right. Now you can save this as relational operators. .py is important, and now I'm going to run this. Let us compare the code. Right, the first statement, 15 less than 18. Yes, 15 is less than 18, so that condition evaluates to true. 15 less than or equal to 18. Yes, 15 is less than or equal to 18, so it evaluates to true. 15 greater than 18 is false, so the result is false. 15 greater than or equal to 18 is also false. 15 equal to 18 is false. And the final statement, 15 not equal to 18, becomes true. This is how you can apply these relational operators and look at the output generated. As I said, every relational operator, when used in the condition, evaluates to either true or false, which is a Boolean result. All right, let's move on. Let us look at some more examples. Instead of directly using the constants in the condition, you may also use variables in the condition. For that, all that you need to do is you need to have some variables in your program. So this is just a small change to the earlier program, and the behavior doesn't change, it would be the same. When you check the condition A less than B, you are ultimately checking whether 15 is less than 18 because the values of the variables are considered during actual condition check. So 15 less than 18 is true, 15 less than or equal to 18 is true, 15 greater than 18 is false, 15 greater than or equal to 18 is false, 15 equal to 18 is false, 15 is not equal to 18, yes, it is true. So I'm going to change the code here. Instead of using direct variables in the condition, I'm going to use variables. For that, I'm going to store the values 15 and 18 into two variables respectively, and I am going to substitute every 15 with a because it is now stored in a variable a. Similarly, every 18 is now stored in a variable b, so I'm going to use b. Run this, compare the earlier output and current output, right? So as you see here, true, true, false, 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 true, 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 false, 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 true. So it is possible to use variables to construct the conditions, and those variables have to be already referred in the program so that you won't get unknown variable error, right? Or name error. So here A and B are already assigned with some value, and based on that these conditions will be checked and these conditions will be evaluated to either true or false. All right, let's move on. The next one is to understand selection control structures in Python. In session 3, what we have learned is we have written different varieties of programs, where we also have written some interactive programs and we also have written some static programs, right? But remember the pattern that we have been using in the session 3 was if your program has 10 statements, all the 10 statements will be executed and each and every statement will be executed once and only once. In contrast, control structures can behave differently. Let us see examples so that we can understand it better. So now in Python, control structures can be divided into four cards coming to the if family. So in the if family, you have four categories. So syntactically, you are going to represent condition structures this way. If is a keyword in Python. If is a keyword in Python. After that, if you need to have a space, then you can write any condition that you want to validate or evaluate. And remember, soon after the condition, a colon is must. Okay. Next is the statement. And look at the space between or space before statement 0. That space is really required, and indentation is what we call indentation is used to understand the scope of a control structure in Python. Hence, all the statements that fall under the scope of that if condition have to be indented properly. Otherwise, you will be getting errors while executing your program in Python. All right. So this is the syntax. If is a keyword, you should use it as it is. It is always lowercase. And whatever condition you want to evaluate, then colon, come to the next line, use indentation and start typing your own statements. And you can write in as many statements as you wish. All right. Then you can also continue to write the rest of the statements in your program, right? So this is called simple if. This is simple if. This is a syntax of simple if and how a simple if can look in your program if you are using a conditional structure simple if. Simple if is one of the conditional structures supported in Python. All right. And how does this simple if evaluate the condition, and how does the result of the condition impact the execution of the program? All that we are going to look at some examples to understand it better. For now, you only focus on the syntax of simple if. All right. The next one, it's the same thing as what you see there, right? In the past, you have seen the simple if, and so far it has been the same, right? All the statements, same condition. If is a keyword, again, you are using if as a keyword. Condition, any condition you want to put there, and you write down any number of statements indented. After that, this is something new. Else is a keyword once again in Python, followed by a colon. And then you can write any number of statements again indented within else. This is called if else. So if else is another control structure, selection control structure to be more precise in Python. All right, this is how you will write the code using simple if. You may also write some code in your Python program using if else conditional structure. All right, I said there are four control structures that belong to if family. The first one is simple if, second one is if else. Let us move on with the rest of the things. All right, next, look at this example. Again, we are using if, a keyword in Python. Condition one, that means we might be using more conditions, right? Okay. Condition one, okay, all right. As you see here, it looks to be if else structure, correct? However, what you can also do is, what Python allows us to do is, you can write another condition within the body of if. However, when you do that, the statements should be indented more towards left, more towards right, sorry. All right. Similarly, in the else block, you can also have another set of if else. All right. And you can also write some general statements which are not related to your conditions. This is another version of how you can write the code in Python using nested if else structure. So this is a syntax of nested if else in Python. Nested if else, right? So on line number 1, you have if, right? And the scope of that if ends with line number 5. On line number 6, you have its associated else, and the scope of else will be ended on line number 10. All right. On line number 2, you have one more if, and its scope is limited to line number 3. The indentation acts as the scope decider in Python. So indentation is very, very important in Python. All right, let's move on to the next category. This is another way. If a condition is met, you will execute a statement. Otherwise, you check one more condition. Like this, you keep on writing more and more conditions and write some code that has to be executed if and only if that corresponding condition is satisfied. Right? This is another way of using a control structure related to if. This is called if else ladder, or if elif is also something that some people call it as if elif. Else if is shortcut to elif, right? Elif is nothing but else if. Okay, so these are the 4 selection control structures that fall under if family that are supported by Python language. All right, now you know how the code can be if you use these control structures, right? Let us take some examples and let us understand it. All right. If you have to look at it in the form of a flow chart, this is how it would be. Start and end are the 2 symbols that we use in flow chart, which are represented by oval shape. Any rectangular box that you see, it is a process. Here, what is a process? It is an assignment process. You are assigning a value true to a variable called is Sunday. Is Sunday is a variable which holds a value true. Okay, and you see a diamond symbol over here. These are the standard symbols that are used within flowcharts. A diamond symbol is used to check the condition. So here you are checking is Sunday. Indirectly, what you are checking is whether is Sunday is a variable, whether it is holding a value true or not. All right. When you check a condition, as I said, a condition will be evaluated to either true or false. Hence, there are 2 possibilities for you. This condition can be either true or this condition could be either false. All right. Now, you pick the path of the condition being true. You assume that, or you pretend as if the condition is true. If the condition is true, the execution flow is represented using arrow symbols over here. So a parallelogram box, this is another symbol that we use in flowcharts. This represents input and output operations. In this case, since the statement is print, you are producing output, right? So if this condition is true, the output would be it is holiday. After that, what happens? This execution flow says go to the next statement, and the next statement is also another output statement, which would also print that. And then we are done with the program execution. If you convert this flowchart into program, we are done with it. However, you did not address the situation or the case where the condition that you have checked becomes false. In that case, you have to also complete that. So assume that this is how your flowchart looks like. Some flowchart looks like this. what would be the output? By looking at the flowchart, we should be able to guess the output. All right. Now we have start. Is a Sunday is a variable which holds a value true, and you are checking the condition whether is a Sunday is true. Yes, is a Sunday is true. Then it gets into the scope. It gets into the flow of yes. It gets into this flow. Then what it will do? It will also execute this statement, which is it is holiday. That means this statement gets executed, and you can see this output clearly on the output screen. Then the flow says that go ahead with this statement. You will also see a statement bye by on the screen, and then program terminates. So if you have to convert this flowchart into executable code or the code, Python code, this is how it will be. Is Sunday equals to false. So in your program, you need to have some variables, right? To exactly replicate this flowchart. So is Sunday is a variable and you have initialized it with false or true, whatever it is. And then here you are checking the condition. See the condition check, the diamond symbol has been converted into if condition. This is example of simply if. And it is holiday. You see that it is holiday has been indented. That means it is holiday is a statement, output statement that is within the scope of the if. And then BYE, the print BYE statement is not indented. That means the statement print BYE doesn't fall under the scope of simple if. All right. And when you execute this code, assume that here is a typo. Let me change this quickly so that you don't get confused. This is true. This should be true, in fact. All right. If this is true, okay, if this is true, the if condition evaluates to true. Then the statements associated with if have to be executed. Here there is only one statement, so you will see the output. It is holiday. After that, it eventually also executes b by b. So the output is both the statements. All right, let us go ahead and let us practice this. So we have some variable called is holiday, which is initialized to true. Then I'm going to check the condition. If is holiday, see colon. You see, I entered and immediately I can see that the statement has been indented. Wherever I am going to type now, that would be indented automatically because I used a colon over there after the condition in the if. So here I wanted to do something like print it is holiday. All right. Then I also want to print by. However, I don't want to have by within the scope of if. All right. What does it mean when I say scope of if? Everything that is indented after the if condition that becomes the body of if. And the body of if, in this case, only one statement would be executed if and only if the condition. So I have to close this. If and only if the condition becomes true. If the condition becomes false, then the body will be completely skipped and the rest of the statements in the code will be executed in a sequential order. You may ask me a question. Where is the condition here? This doesn't seem to be a condition because you don't see any of the six relational operators. That's a good question. However, this is acted as a condition because this is a Boolean variable. When you have a Boolean variable in your condition, Indirectly, you are asking, please tell me whether this Boolean variable holds a value true or not. Alright, in this case, this holds a value true because you yourself have assigned a value true to this. So the condition becomes true. When the condition becomes true, the if body has to be executed, hence the output would be it is holiday. Story doesn't end there because there are some more statements in your program, so they also have to be executed. Hence, the output by can also be seen on the screen when you execute this program. Let me save this as separate program before I execute it. I'll call it as simple if with a value true, right? Any name can be given to your file and run this. You see, you see both the statements. From where did you get these two statements? Compare it with your code, right? As you see here, is holiday is a variable which is assigned with value true, sorry, and you are checking for the condition. Yes, it is true. So the body has to be executed. So it is holiday is printed. That means the body of it has been executed, and also the by statement has also been executed. This is how you can compare the program that you have written with the output and understand what lines of this has contributed to the output that you have received. All right. What if the value of this variable is initialized to false? Now the condition is evaluated to false, right? Condition would be evaluated to false. When if condition is false, what happens? As I said, the body should not be, the body will be totally skipped. What is a body of if? It is only one statement. Why? Because there is only one statement indented within if. So you don't see this statement getting executed. Then what would be the output? The output would be by. Only the body of the if will be skipped, but there are some other statements in the program to execute. So now if I execute the same program, you can see an output of only one line, which shows you by. Okay, now let me save this file before I execute it. And run it. As you see, there is just one line of output, right? And you know the reasons, right? So there is a Boolean variable which is initialized to false. It is used in the condition. Now the condition becomes false. When the condition becomes false, the entire if body has to be skipped. That means that won't be executed at all. So this is not going to execute when you execute your program. Now there is only one line of output which is fine. All right. This is how you should understand the scope of if. Okay. And interestingly, if I indent this by as well, now can you guess the output? Let us try to understand this program now. The variable is initialized with false. The condition becomes false. When the condition becomes false, the entire body of the if has to be skipped. That means what is the body of if here? Both the statements. How can I say that? Because both the statements are indented, right? They're to right. They are not on the first column. They are indented. They are moved to right. Hence, these two statements are not going to be executed now because the condition is false. And if you run this program, there won't be any output. There won't be any output produced. See, Program is executed, but there is no any output produced. Understood? This is how the simple if can be used. Say I write I am done. Now what would be the output? For the same value of false in is holiday. Condition is false. The body, meaning these two statements have to be skipped. However, this statement has no dependency on this condition because it is not indented within the if block. Hence, this will always get executed whether or not the condition is going to become true or false. Hence, the output would be I am done in this case. Let us try it out. Yes, I am done is what you can see here, right? All right, this is how you can use simple if, right? You can use simple if and instead of Boolean variable, this time I'm going to use some integer variable. I can say is equal to 10. Now I can check if A is greater than, let us start with less than operator, the very first relational operator we have discussed. If A is less than 20, I want to do these two statements. I want to execute these two statements. Otherwise, I want to execute this statement. So now tell me what happens to this condition. What this condition evaluates to true or false. 10 less than 20. It is true now. True means body has to be executed. So you can see both these statements executed so that you will see it is holiday by after that you will also see this statement getting executed. Hence, you will see all the three statements producing output in this case. Let us try that out. Yes, you see, it is holiday by I am done. Correct? To make it more meaningful, I can say that A is less than 20 is what you're using. I can write a statement like this. Right? And probably I can have only one statement within the scope of if, in the body of if. Okay. Now a value is 10, 10 less than 20 is true. So the if body has to be executed. It prints a is less than 20. If you want to print the value of a also, you can write it outside and you can use a comma and here you can remove this. Now the actual value of a, for example, 10 is less than 20 is what you can see. Correct? Let us try that out. Yes, 10 is less than 20 and I am done is the one that executes, that statement executes irrespective of the condition. What if I change the value of a and execute it once again? Let us check it. A is 15, 15 less than 20. What happens to this condition when you evaluate it? It becomes true. Hence, the body has to be executed. This time, a value is 15. So you can see the output 15 is less than 20, and you will see I am done. Run this once again. 15 is less than 20, I am done. All right. What if I make the value of a as 150? Let us try. 150 less than 20 is false. The condition is false. When the condition is false, the body of if has to be skipped. None of the statements from the if body have to be executed when the condition becomes false. Hence, the only output you can see now is I am done. As you can see, the output is just I am done. This is how you can use variables along with constants in the condition. You can use 10 less than 15 directly, or you can use variable on one side and the constant on the other side. Anything you can try, any combination you can try here. But keep in mind that if the condition is true, if body has to be executed. If the condition is false, if body has to be skipped completely. How do we decide the body of if? What is the scope of if? It is by indentation in Python. So the number of spaces here, okay, will tell us how many statements belong to if and how many statements are outside it. For example, I do some zigzag. I am not consistent on this. I'm just putting something like this, and I am just going to add one more statement like this, right? So I would say, like, now let us execute this program. As you see, unindent does not match any outer indentation level. What does it mean? Your indentation is not consistent. There is nothing, there is no any indentation scope with how many spaces here? One, two spaces, right? So either you put it inside the block of if or put it outside the block of if. If you have to put it outside the block of if, you have to completely put it at the same column where your if condition has started, right? The column. So now you won't get any error, correct? That is how indentation is very, very important. Indentation in Python is used to decide the scope of a programming construct. All right. Well, be very careful about this indentation. As a beginner, when you are practicing Python for the first time, you may get confused with these indentations and you may not follow these indentations properly. Hence, you may get such errors, right? Whenever you get an error, like what you was just seen, it has to immediately hit your my brain that somewhere I missed the indentation. My indentation is not consistent. Indentation is nothing but moving the statements to the right side, right? So that the scope of a conditional structure is defined. Python will identify the scope of a conditional structure. In this case, it's especially, it's not only for conditional structure, but for repetition structures that we are going to discuss later. Also, the indentation is very important. And that's the only way for Python to understand what falls within the scope of if block and what doesn't fall within the scope of if block. All right. Now, let us move on. What if the variable has been initialized with false? Of course, this is what I have already shown you. And if you have to convert this flowchart into a code in Python, this is how it would be, right? Is Sunday is a variable? Yes, you need to maintain a variable in your program, and then you have to use that variable, Boolean variable in your condition. And of course, if the condition is true, you wanted to print it is holiday. That's why you are making that it is holiday statement as part of if block by indenting it, and the statement print by is going to execute irrespective of whether the condition is going to become true or false. Hence, there is no indentation used for print by, and in this case the output will be by. Why? Because is Sunday is holding a value false, that means your condition has evaluated to false. When the condition has become false, you have to skip the body of that control structure. Hence, it comes out of the block. That means the line number 3 will be skipped and line number 4 will be executed. Hence, you see the output only by. All right. What if you see code something like this? As you see here, again, the same variable, Boolean variable, is Sunday, has a value true, and you're checking the condition once again. As I said, when you check a condition, there are two possibilities. Your condition may be either true or it can be false. Any condition evaluates to either true or false. That's it. There is no other third value. It is a Boolean. That's why we call the result of a condition is we say that the condition always evaluates to Boolean result. All right. What what would you like to do if the condition evaluates to true? That is what is mentioned here. Use print it is holiday. If the condition is false, use print by. And remember, every flowchart must have start and stop indicators. Hence, you have to also, you cannot stop there, but you have to finally, there are two flows coming out here. Okay, two execution flows is what we call. Okay, when the condition is true, the control will go to true part of the flow chart, left side part. When the condition is false, it comes to the right side part of the flow chart. But in both the cases, once it does its job, it has to stop the process of program execution. Hence, from the flowchart perspective, we represent it this way using arrow symbols indicating the flow of execution and finally the start symbol. All right. Now, if you have to convert this into a Python program, how would you do that? Again, sorry, here is a typo. Give me a second. I'll just change this to true. All right. If we have to convert this flowchart into Python program, this is how it looks like, right? You have a variable with a value true. You're going to check the condition. So in your flowchart, every diamond symbol will be converted into a condition, right? If is Sunday, yes, first write down the if block using indentation. So there is only one statement to execute, right? If the condition is false, what you need to do? You need to print by. But again, remember, there is a difference between earlier program and this program. You have to print by if and only if the condition becomes false. Hence, you should use else and then write down by. All right. So this flowchart can be converted into Python code this way. Let us go and practice this. Is Sunday. Set to true. You are going to check whether it is Sunday. If is Sunday, print it is holiday. All right. And remember, if the condition is false, we need to do something else. When I say something else, you put it in else. Put it in else block. And according to the code, the example you have seen, it should be something like by, and maybe if you want to put a full stop, that's okay. Otherwise, leave it. And I may say, okay, leave it for now. I'll just come back to this once again. This is how your code looks like, right? If the condition is true, if block will be executed, that means it is and it is holiday will be executed. And then remember, once the if block is executed, else block will be completely skipped. All right. In this case, the condition becomes true. So if body is executed and else body will be completely skipped. Let us run this. The output expectation here is it is holiday. Yes, as you see here, it is holiday has been printed. Why? The condition becomes true. That means if body has to be executed. This is if else. In case of if else, Once the if body is executed, else body will be skipped. All right. Now, what if I put false here? I have initialized the variable with false. Now the if body condition has become false. When the condition becomes false, if body will be skipped, but else body will be executed. Either that or this, right? In the case of if else, either if body should be executed or else body should be executed. Who dictates that? The evaluated condition, the result of the condition decides that. All right. Now the condition is false, so else body has to be executed. Now you can see an output of VYE by when you execute this program. All right, there is just an output of by, right? What if I have a statement like this? For example, like this. You can you guess where this print gets into? What is the scope of print? Will it execute if the condition is true? Will it execute if the condition is false, or will it execute irrespective of the condition value? Remember, since it is indented within the block of else, it gets into the body of else. And else body should be executed if and only if the condition becomes false. Right now, the condition is false, hence you can see both BYE and I am done executed. It is all purely indentation based decision making while deciding the scope of a control structure. And now, if I just change the indentation, now this statement does not rely on the condition of if. It executes always. Why? Because this is not within the scope of if. This is also not within the scope of else. Hence, it gets executed always. For now, is Sunday is false, condition becomes false. So else body has to be executed. You can see BYE by. After that, it also goes and executes I am done. So let us run this. As you see, we got both by and I am done. Now I am going back to change the value. Now guess the output. Condition is true. That means if body has to be executed. So it is holiday will be executed. Once the if body is executed, else body will be skipped. What is else body? There is only one statement within else body, and it continues to execute the rest of the statements in the program. So you can see I am done executed. Finally, the output would be it is holiday and I am done. Two statements. You can see it is holiday also I am done. Both the statements are produced in the output. Clear? This is how you need to understand if else. All right. How do you go with numeric values? Again, A is 10, and you can write if A is less than 10, I can write the same statement, right? A is less than 10. Otherwise, see, this is interesting, right? You can say, otherwise what? What is a true condition? A is obviously greater than or equal to 10. And you can also have this I am done as it is. So let us understand this. A is 10, 10 less than 10, true or false? 10 less than 10, false. So if body is skipped, it comes to else body, it prints A is greater than or equal to 10. That means it prints the value of A 10. 10 is greater than or equal to 10 is what it prints, and it also prints I am done. Run this program. As you see, 10 is greater than or equal to 10, I am done. Let us change the value of a to 100, for example. Now, 100 less than 10. The condition becomes false, which indicates you should execute else body. So you will once again see 100 is greater than or equal to 10, and also I am done. All right. 100 is greater than or equal to 10, and you can also see I am done. Let us change the value of a to 1. What if the value of a is 1? Check the condition. 1 less than 10. True. When the condition is true, we need to execute if body. And the if body here is this. So the value of a 1. 1 is less than 10 is what you can see. Since the if body is executed, else body has to be skipped. You should not enter into the else body once you have executed the if body. So you come here out and it will also print I am done. So the output would be 1 is less than 10, and on the next line I am done. 1 is less than 10, and then I am done. Clear? All right. This is how you can use if else, right? And for example, here you may also use second variable if you want. B is equal to some other value. You can also use B here. You can check the condition, and accordingly you can write your own statements in both the if block and else block. And if required, some statements which are independent of the condition of the if, and you can proceed ahead. Clear? All right. Let's move on. Hope you understand simple if structure and if else structure. If you have already and if you understood this concept, okay, and the output produced, please subscribe our channel, okay. Also like, share. Also, you can also support us. You can also subscribe, and you can also support us on the social media platforms. And you can go to technolearnit.com on the browser. Okay, it's a website. Go there, and you can get all this material from the previous sessions. Also, what our material it has been covered, what are the topics have been covered. All that material is available over there for you to download and practice. And by the end of the session, you will also get all this content updated over there for your quick reference. And I would strongly suggest you to practice. If you don't practice, you won't be better at programming. The only secret of being good at programming is to practice. If you have any questions, you can put them in the chat. I'm here to answer. If you have any kind of questions on any kind of topics that were covered so far, you put it in the chat. I can help you out. Okay. All right. Let's move on. So in this example now, can you guess the output? Quickly check it. You should be able to guess it by now. There is a variable, Boolean variable with a value true. All right. And the condition becomes true then. So if body has to be executed. So the output would be it is holiday. Since the if body has executed, else body should not be executed. So the only output would be a single line, which is it is holiday. Great. What if so we are talking yeah, Satya, we are discussing the programming constructs in Python, out of which there is a classification of programming constructs, and we are mainly focusing on If a family is divided into four parts, simple if else, nested if else, and if else ladder, and I'm covering one after the other. The syntax and a flowchart and how that flowchart looks like when you convert it into Python code and how to guess the answers by looking at the Python code is what I am covering. Are you comfortable? All right. So the output here would be what? Now the value of the variable is false. The condition becomes false. Hence, if body should not be executed. If body is skipped, else body is executed. And the output would be by. That's it. All right. Now, whenever you see a simple if else, nested if else, or if else ladder, you should understand that your program is using selection flow or selection control. Okay. And now let us practice some programs and let us understand how to write some programs using simple if. The first one you see here is to check whether the person is eligible for voting based on his age, right? So how do we do this, right? Do you remember a program that we have practiced in the last session where the age is taken as input from the user, correct? Name and age of a person, right? So you can probably take the age of a person as input so that you can decide whether he or she is eligible for voting. You can add a prompt in the input, right? Input function, enter the age of the person. So the user entered age will be stored in the variable called age. Now, if the age is less than 18, okay, you can say that person is not eligible for voting. Okay, what if the interviewer asks you to use only simple if and nothing else? How can you write this program using only simple if, right? See, when you are deciding whether a particular person is eligible for voting or not, there are only two options. What are those? Either he would be eligible or he may not be eligible, right? Only two cases, right? Either of those two cases should be satisfied. So what you have to do is you have to repeat the same condition, but you have to write the counterpart of the condition. What you're also saying is, see, for less than, the opposite condition would be greater than or equal to. It's not greater than, remember, you should use greater than or equal to. And now, here what you can say is, person is eligible for voting. Okay, and that's all. There is no any common statement to produce as output, either this or that. And remember, either of these two if conditions only will be satisfied. Say for example, pass the age of the person is 20. Says person is eligible for voting. Here, I run this once again with an age of 15. Person is not eligible for voting. How many statements do you see? How many output statements do you see in this program? Output statements. There are two output statements. Print statements, no? Person is not eligible for voting is one statement. Person is eligible for voting is other statement. At any point of time for any input, there is no case where both the statements will be executed. Either this or that only will be executed. That is why this is called selection structure. Select the statements to be executed based on a condition among the statements that are available in the program. That's why this becomes selection structure or decision controlled structure. You are deciding what part of the program, the statements from what part of the program have to be executed based on a condition. That's why this becomes decision controlled structure or selection structure. All right. So this is how we can write a very simple program, which is a dynamic program. Once again, it interacts with the user. It is an interactive program. It asks the user to enter the age, and accordingly, it will decide whether that person is eligible for voting or not. You remember, this is how you have used conditional structure meaningfully to write subcode. You have used only simple if, and if there is no any restriction to use only simple if, you can use if else, which is most appropriate structure, conditional structure to achieve this. All right. So what does this really do? The condition is true, body is executed, else body is skipped. The condition is false, if body is skipped, but else body is executed. And that's the same behavior we are seeing. And remember, when you are using else, when you are using else, there is no need to write the same reverse of this condition once again, because there are only two possibilities that you are looking at in this context. So this program also should produce the same output as earlier case. So I once again try it with the 20. Yes, person is eligible for voting is what it says. Awesome. Let us also try it with 15. It says that person is not eligible for voting. So in the earlier version of the program, I have used simple if two times, and in this case, I have used if else structure. Correct? What if the input is exactly 18, 18? 18 less than 18, true or false? 18 less than 18 is false. So it comes to else block and it says person is eligible for voting. So if you come down, enter 18, says that person is eligible for voting. So either you can use a simple if or if else structure to achieve this kind of control flow or execution flow of the program. Clear? And one example I would like to cover, when will you use simple if, is that, say example, um, I'll give you a number, okay, and that number can be either positive or negative. Enter any number, okay, and what you have to do is, if number, how do you decide whether the number is positive or negative? Programmatically, how does a program decide whether the number is positive or negative? So what you can do is, any number that is less than 0 is always negative. Okay? And what I wanted you to do is, once I give you a negative number, you have to convert it into a positive number. So you can say, how do you convert a number into positive? You can just simply multiply it with minus. Correct? When you multiply a negative number with a positive number, its a sign changes, but the magnitude doesn't change. Right? That is what I want. So what you are doing is, only if the number is negative, only if the number is negative. How did you decide that whether the number is negative or not? You are comparing the number against 0. If the number is less than 0, that means absolutely it is negative. So you are multiplying it with -1 so that the number becomes a positive. All right. Now, if I give you 5, there is no change you need to apply. 5 has to remain as 5 only. So this is called absolute value. Okay. Absolute value is always positive. Keep that in mind. Okay. Absolute value is always positive. So you just put a comma over here and just type in number. Okay. Great. Let us understand how this program works. It first prompts us to enter a number. Say I give you -5 as input. -5 will be stored in number variable. -5 less than 0 is true. Negative number, no? Negative numbers are always less than 0. So now it comes and executes the statement. The body of if, because the condition is true, it has to execute the body. Number is -5. -5 times -1 is -1 times -5 is +5. So this result of this expression on the right hand side will be assigned to number. Now, since we have stored the result in the same variable, the number becomes the -5 stored in number will be overwritten with +5. Now number value is 5. Now the absolute value is 5 is what you anyways see in the output because this statement is not related to the condition. Let us try this out. You pass -5, but you get absolute value as 5, correct? So when I give a negative number, your program has converted into positive and it is going to produce out. What if I myself give 5 here? I give positive number only. Of course, absolute value of +5 is 5 only, right? Here, make sure you understand the requirement here. The intention is not to change the sign of the variable. The change of the sign of the variable or the value has to happen if and only if the number is negative. All right. When the number is negative, then only you have to convert it into equivalent positive number. That can be achieved by multiplying it with minus. Once you multiply any number with -1, since it is already the number is already negative, it becomes positive with the same magnitude. That is called absolute value. So to find the absolute value of a number, what is the programming construct you have used here, or what is the decision control structure you have used here? This is nothing but simple if. There is no else associated with it. So this is simple if. So simple if can be used to find the absolute value of a given. All right. And to check whether the person is eligible for voting or not, you can use simple if, or conveniently, more conveniently, you can use if else. All right. So with this, we have completed the code to check whether the person with given age is eligible for voting or not. Let us move on to the next program. Check if a given number is positive or negative. Of course, very much close to what we have just discussed. There is a number given to you, but you have to decide whether it is positive or negative. All right. Now you tell me I don't want to change this condition. Then how? What is that you need to write here? If number is less than 0, what will you write? Huh? Number, yes. Is number is less than 0, then what is it? Is it positive or negative? It is negative. Or it will say it is less than 0. That's it. Right. How do you know if the number is positive? If you are supposed to use only simple if, you can check like this. If number is greater than or equal to 0, assume that I am considering 0 as positive in this case, unless mentioned otherwise, right? Number is greater than or equal to 0, and you have to open the single quote or double quotes here. All right, let us run this. Say I pass 12. Says 12 is greater than or equal to 0. Yes, 12 is greater than or equal to 0. Correct. I enter. So did not run it. I'm running this one second. Um, the number is -3, for example. It says -3 is less than 0. And what if you run this? I'm going to use shortcut now, which is F5 to run the program. I give input as 0. And now it says that 0 is greater than or equal to 0. Does it make sense? All right. So this is how you can use simple if to check whether the given number is positive or negative. If you want to detect 0 as explicit case, then you can, of course, you can write one more simple if. If number is exactly 0, how do you check exact? Equal to equal to. You can say print number is 0. Makes sense? In this case, you should not say equal to. You should always say greater than 0. You should not say equal to because you are not using equal to operator in the condition check. So you have used three simple if structures, control structures in this program. Let us run this now to check all the three different cases. First case, I pass 56 first. 56 is greater than 0, which is correct. Run this code again. Shortcut. -45. Yes. -45 is less than 0. You run this one more time. This time I pass 0. It says 0 is 0. Right? This is how you can use simple ifs in this context. If you want to be more precise or more conveniently, what you can also use is you can use elif. When to use elif? Let me explain you. What if you don't use elif in this case? You're still able to produce the output. But the point here is, say you have given a negative number as input. Once it checks whether the negative number is less than 0, yes, the condition is true, execute this. Unnecessarily, it still goes and checks the rest of the conditions also if you use simple if. Whereas when you use elif or else if, right, it won't go and check the rest of the piece of the code. The moment this condition is true, it skips everything in the else block. So this is how the program execution time can be better if you use elif, and you can avoid unnecessary checks once a condition is met and you have already produced the output as expected. That is how else if can be used or elif can be used to have better performance of your program execution. Make sense? Run it once again. 77 is greater than 0. I may have to I don't know, greater than 0, I can say no. Just a small change in the way the output is produced. I'll give a negative number -98. Yes, -98 is less than 0. Right? I'll give input as 0 exactly and 0 is 0. Right? So this is how you can use elif. If else ladder is what? we have discussed, and this is nothing but if else ladder. There is a condition. What if that condition is not true? What other condition you need to check? Write one more condition, right? So this is condition one, this is condition two, this is condition three, and of course you can write else and write something else also. Or you can also write any generic statement over here, right? So this is how you can use if else if and check as many conditions as you wish. All right, let's move on to the next one. Check if a given number is positive or negative. Sorry, it has repeated. Actually, the intention is to also check for zero. I have already covered that, so I'm going to the next one. Check if a given number is even or odd. Interesting. So how do you check whether the given number is even or odd? So you read the input, well and good. And how do you check whether the given number is even or odd? Right? All the even numbers when divided by 2 will produce the remainder as 0. This reminds me the remainder operator is nothing but modulo division operator, right? So you use that operator, you divide the given number with 2 and sorry, check if the remainder is 0. How do I check whether the remainder is 0? The operator itself I am applying gives me remainder. So I am checking whether the number mod 2 is equal to 0. If it is, then the number is even, correct? Any number when divided by 2, if produced remainder as 0, it should be even number. Say for example, you are supposed to use only simple if. In the interview, the interviewer has asked you to write this program only using simple if. You are not allowed to use any if else or anything else. So how do you do that? Again, you have to repeat this same condition, but you have to use opposite condition. For equal to, it is not equal to is the opposite condition, right? So not equal to 0, then number is, you can say, this is how the same program I am showing you how to use simple if. I am also showing you how to use if else, and wherever possible I am also showing if else ladder. Okay, 23, is it odd or even? It is an odd. So 23 is odd. Yes, the program has produced right output. I'm going to run this once again. This time I'm going to give an even number, 34. Yes, 34 is even, right? So one more time, 0. 0 is even or odd? It's even. So 0 is even. This is how we can check whether the given number is even or odd using simple if. How do you convert this into if else? Say you are permitted to use if else. You can use else. And you don't need this condition to be written explicitly in that case. You can just say if the number condition is to do this, otherwise else do this. That means print it as odd. And if the condition is true, print it as even. And if the condition is false, that means that when you divide a number by 2, there are two possibilities of remainder, 0 or 1. So if it is 0, you will treat it as even, and this output will be produced. When this condition is false, it prints that the number is odd. Well, all right, let's move on. The next one is to find the greatest of two given numbers. Well, you have to read two inputs. Enter the first number. I call it as first underscore number. And you need to also read the second input, for which I'm repeating this same input statement and writing it in second and store it in a different variable. All right. Now, how do I know which one is greater? Unless I check, I won't be able to know that. So I have to check. How do I check? What to check? I have to check if first number is, we are supposed to find a maximum, no? So if first number is greater than second number, right? If the first number is greater than the second number, then you have to print which one is greater. The condition itself tells you, right? First number is greater. So print first number is greater. Again, else will directly tell you that second number is greater. So you can right away say second number is greater. All right, let us run this. First number is 12, second number is 34. Yes, 34 is greater. The condition itself drives the execution. 12 greater than 34 is false. That means else body has to be executed. That is where you print 34 is greater. Run it one more time. This time I will reverse the input. 32 and 12 maybe. Yes, still it can tell me which one is greater. How? This time whether the if body is executed or else body is executed. If body is executed, why 32 greater than 12 is true, so if body is executed, else body is skipped. What if you are not allowed to use else? How do you write the simple if condition for this? Using simple if, how do you achieve this? If first number is less than or equal to also input, because there you use it greater than, now the counterpart is less than or equal to, and you have to compare this with second number, right? Exactly opposite condition you have to write. If you are not allowed to use else, if else, you have to use only simply if, right? So again, same story. I'm giving the same input just to show you that it works well. 32 is greater, yes. And I'll just reverse the input and also show you one more run. 12 and 32. Still it can detect 32 as greater number. The only difference would be whether if block is executed or else block is executed, right? And the extension to this is you should also detect that both the numbers are same in such cases. For example, in this case, what happens? When I give 32 and 32, it just says 32 is greater. Really, 32 is not greater than itself, right? But the condition, the code that we have written is not going to identify that situation. If you have to really identify that situation, then you have to write it as a separate condition for that. How? Right? But a check for equality, simple. Okay. First number is same as or equal to whatever. You can put first or second, doesn't matter. Both are one of the steps. Now run this code. Hmm, I did not use comma over here. The type syntax. Run this. All right, 32, again 32. Yes, it says 32 is same as 32. It doesn't say 32 is greater or it doesn't say 32 is smaller. Correct? So this is how you can keep on adding more and more conditions to your code based on the need or based on the requirement in front of you. And what if you are supposed, what if you are allowed to use else if or any other things? You can just put a if here. It will just increase the program execution performance of the program actually, because when you're checking two conditions, if this condition is true, there is no chance of having the other two conditions becoming true once again for the same set of input. That's the reason if you put else if, this will never get executed at all. Makes sense, since the first condition is already true. Say first condition is false, but the second condition is true, then it won't come and execute this. You don't even check this condition. That is how you can limit the number of statements executed in your program by using else if. So I give 12 and 45, and 45 is greater, obviously, right? So this is how you can use simple if else or nested if else, right? Let us move on to the next program. Next one is self-explanatory, smallest of two given numbers. Instead of greater, this time it is smallest. So how do you achieve that? This is quite simple. You can just invert the operators. Oh, sorry. You can instead of greater than, you can use less than, and wherever there is greater than, you use less than, and wherever there is less than, you can use greater than. Equality doesn't change. As simple as that, right? And you want to see smaller, no? So change this to smaller or smallest, whatever, right? Equality will not change, same as will be as it is. So 15 and 10, 15 and 10, if you, for example, if you give as input 15, 15 less than 10 is false. So it comes here, right? 15 greater than 10 is true, prints 15 is a smaller, which is wrong, no? So since I have changed this description, I should keep these things as it is. 15 greater than 10, true, then it prints 15. Sorry, wait for a second. I need to change these things also, no? When 15 is smaller, first number is smaller than second number, I should say that first number is smaller. Correct. And if first number is greater, I should print second number is smaller. Correct only, right? So, for example, 10 and 15 is the input. 10 is less than 15, which is true, then it prints 10 is smaller. Then it won't go and check these conditions. Say, for example, the input is 15 and 10. 15 less than 10 is false. Since this is false, it checks this condition, second condition. 15 greater than 10 is true, then it reads 10 is smaller, right? And it doesn't come and check this condition because it has already executed the body here. All right, let us switch this now. 10 and 15, 10 is smaller. 14 and 18, 14 is smaller. One more run. 20 and 12, 12 is smaller. One more run. Multiple cases you are checking to make sure your program works in all the cases. 12 and 12, 12 and 12, for example. 12 is same as 12. So it can detect all these three cases based on the way you have written the program, right? So this is where we have used if, else if, and else if. All right. So this is how you can use selection structure. And we have mainly covered simple if else, and else if else ladder. And this if else ladder is also important to write some programs with good formatting. For example, I give you a digit as input. Digits in decimal number system are 0 to 9. There are 10 digits. Right? You can read it into digit variable. What you need to do is your program has to do is if the digit is 0, you have to print ZERO. If the input is 1, ONE you have to print. So you have to check now. If digit equals to 0, see like this, how many conditions you need to check? You have to check all the 10 conditions. There is no other way. So this is where else it will really help you out, right? Because a digit can be either of these 10 possibilities for a given input, correct? Cannot be more than one at a time. A variable can hold only one value at a time. You can check if digit is 1, then you need to print ONE. Printing the given digit in words, that's what we're doing here, right? And if digit is equal to 2, you have to just print TWO, right? So I can repeat this. Sorry, I can repeat this, paste it to save some time. Let us say 2, 3, 4, 5, 6, 7, 8, 9. Interestingly, if none of these conditions are met so far, it means it is not a valid digit. You can simply type in, I'll show you that example as invalid. Interestingly, this is going to have more number of lines of code that we have ever written so far. However, it is very simple if you understand the logic. I pass in 7. Yes, the output is 7. Great. In words, printing the given digit in words. And write for all these inputs. For example, if the input is 0, it produces 0. Yes, well. However, what if the user gives 87 as input? It's not a digit at all. There are only 10 digits, 0 to 9 inclusive. Whereas in the user has provided an input of 87, which is an invalid digit. And in such cases, all these conditions will be checked. Then finally it comes to else and it executes this. When you have given input as 0, it produces this output and it won't check any of these conditions because it has already identified a true condition. This is all else if. This is how else if it's used. Well, so this is how you can use decision control structures in your program to develop some meaningful programs, right? All right, the same thing you can also use if else. I have been showing this in every case. I was converting the same program into if else also wherever possible, and I was showing you. So this brings us to the end of session 4. And in the next session, we are going to use repetitive structures or iterative structures. These are also called loops. There are a variety of programs which are also important from your academic perspective as well as interview perspective. So stay tuned for next live session. Till then, please subscribe and follow us, and there will be quizzes posted on YouTube channel every day. So watch them and watch them till end to understand the answer, to get the answer, because answer is included in the same shorts, YouTube shorts. So all the best. Have a great coding experience and happy coding. Take care. Bye.